AP Cram, Calculus AB, Free Response Exam Review. Question 64. Volume of a solid, square cross sections. Okay, so let f of x equals 2x squared minus 6x plus 4, this curve right here, and g of x equals 4 times the cosine of 1/4 pi x, this curve right here. Let R be the region bounded by the graphs of f and g as shown in the figure. So the intersection of these two regions bound the area R, okay? All right, so this is what we have to sort out. The region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a square, okay? So what we are to do is write, but not evaluate, an integral expression that gives the volume of the solid generated by perpendicular cross-sections. I'll give you a moment to think about your solution. And for those of you who are unable to think of an integrand or visualize what's going on, it's really not that bad. Just sit tight and the solution is coming up. All right, so we have to come up with an integral expression for the volume of a solid whose base is region R. But the cross sections of the solid are perpendicular to the x-axis, and these perpendicular cross sections are squares, like as such. All right, so if you were to summate all of the possible cross-sectional squares whose base is R, you would get the volume of the solid. And in order to come up with the required integrand, we need to know basically just the side of one of these squares, because the area of a square, or the cross-sectional area of these squares in this case, is just going to be the side squared. Well, the sides are just the difference between g of x and f of x. So if we take the height of g of x and subtract f of x from it, we get the difference between them, okay? And so taking the integrand from 0 to 2 is just going to summate all the possible squares in this region R, thus giving us the volume of the overall solid. So the volume is equivalent to the integral from 0 to 2 of g of x minus f of x, because this is one of the sides and the area of a square is a side squared, multiplied by dx, the change in x, which is going to give us our volume, okay? So now all we're left with to do is plug in the expression for g of x and f of x, and we get the integral from 0 to 2 of 4 the cosine of pi over 4x minus 2x squared minus 6x plus 4, all of this squared times dx. All right? Okay.